Assalamualaikum warahmatullahi wabarakatuh. We're from class tutorial SS2. For FAG1004, we're going to present set B. Before we start, let me introduce myself. My name is Saiful Nazmi with matrix number 240000510. So for question number 1, without using calculator, find the value of x given that square root x plus 8, square root x plus 8, square root x plus 8 equals to 2 power of 7/2. So firstly, we need to separate the equations at the left side. So it will be x plus 8 power of 1/2 times x plus 8 power of 1/4 times x plus 8 over power of 1/8 equals to 2 power of 7/2. So when we have power and this, we can add it together. So it will be x plus 8 over power of 7/8 equals to 2 power of 7/2. Next, when we have 2 power of left side and right side, we can cancel each other. So it will be x plus 8 power of 1/8 equals to 2 power of 1/2. So from here, we need to log it both sides. So it will be 1/8 log x plus 8 equals to 1/2 log 2. So from the base, we can 1/8, we can put it on the right side, and it will be 8/2, which is 4. So we get log x plus 8 equals to 4 log 2. So we put 4 to the power of 2. So 2 to the power of 4, we will get log x plus 8 equals to log 16. So we cancel log of both sides. We will get x plus 8 equals to 16. Lastly, we will get x equals to 8.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amsyar bin Nazmi and I'm from SS2. My question is, given z equal to 4 plus 2i, write the expression 6i to the power of 73 over the conjugate of z. Okay, first of all, start with the given complex number z equal to 4 plus 2i and find its conjugate, which is 4 minus 2i. And then we need to simplify I to the power of 73, since powers of I repeat every 4 terms, which is with I to the power of 4 equal to 1. Divide 73 by 4. The remainder is 1, so I to the power of 73 equal to I. And then substitute I to the power of 73 equal to I into the expression. This given us 6i over 4 minus 2i. And then to simplify, multiply both the top and bottom by the conjugate of the denominator, which is 4 plus 2i. Other than that, after expanding, we get 6 plus 3i over 5. And finally, write the answer in standard form as 6 over 5 plus 3 over 5i. That's all from me. Thank you.
Hi, my name is Joywna Celestie, anak Joywna Celestie. I'm from SS2 and I will be presenting question 3 from set B. For the expansion of 2y plus 3x to the power of 2 to the power of 9, find A, the first 4 term, B, the coefficient of y to the power of 2, and C, the last 2 term. So we will start with the first question, which is A, find the first 4 term for the expansion of 2y plus 3x to the power of 2 to the power of 9. So this is the formula to find the value for the term. So the question asks for only first 4 term. So as we can see here, the value of A is 2y, B is 3x to the power of 2, N is 9, and our K is 0. Why 0? Because the question only asks for first 4 term, so it will start with 0, 1, 2, and 3. So we can just insert the value into the formula, which is 9C0, which is our 9 is N, NCR, NC, and our value, our K is 0. So 9C0, 2y to the power of 9 plus 9C1, 2y to the power of 8, 3x to the power of 2 plus 9C2, 2y to the power of 7, 3x to the power of 2 to the power of 2 plus 9C3, 2y to the power of 6, 3x to the power of 2 to the power of 3. So after we insert all the value in the formula, we will get the answer. So for the first term, 9C0 multiplied by 2 to the power of 9, we will get 512y to the power of 9. So for the second term, which is 9C1, we will multiply by 2 to the power of 8, multiply by 3 by 3. So we will get the answer, which is 6912y to the power of 8, x to the power of 2. And then for the third term, which is 9C2, we will multiply 9C2 with 2 to the power of 7, multiply it to 3 to the power of 2. So we will get the answer 41472, y to the power of 7, x to the power of 4. So for the fourth term, 9C3 will be multiplied by 2 to the power of 6, multiplied by 3 to the power of 3. So we will get the answer 145152, y to the power of 6, x to the power of 6. So we already solved this question because it only asks for the value of first four term. So the first term is 512 y to the power of 9. The second term is 6912 y to the power of 8 x to the power of 2. The third term is 41472 y to the power of 7 x to the power of 4. And the fourth term is 145152 y to the power of 6 x to the power of 6. We move to the question B, which is find the coefficient of y to the power of 2 for the expansion of 2y plus 3x to the power of 2 to the power of 9. So this is the formula to find the coefficient of this expansion. So before we solve the question, we must find first the value of n and r. So we already know the value of n, which is 9, but we didn't know the value of r, which is unknown. So how do we get the value of r is 2y to the power of 9 minus r is equal to y to the power of 2. So if we want to find the value of r, 9 minus r equal to 2, we will get the value of r is 7. So after we get all the value, 9 and 7, we will insert the value into the formula. So for this question, I will use the formula NCR. So I will insert the value. So we will get 9C7, and I will rewrite this 2y to the power of 2, 3x to the power of 2 to the power of 7. So if we calculate the value, we will get 36 for 9C7, and we will get 4 for 2 to the power of 2, and we will get 2187 for 3 to the power of 7, and x to the power of 14, because x to the power of 2 multiplied by 7, we will get x to the power of 14, and y to the power of 2. So we can find the value already by just multiply all the answer that we find, which is 36 divided by 36 multiplied by 4 multiplied by 2187, and we will get 314928 x to the power of 14 y to the power of 2. So for the answer, for the coefficient of y to the power of 2, we will get 314928. Last, for question C, find the last two terms for the expansion of 2y plus 3x to the power of 2 to the power of 9. So the formula is same like what we did before for the first four term, but for this question, the last two term, we will find the term for term 8 and 9. So our K will be 8 and 9. Our A, 2y, B is 3x to the power of 2, n to the power of n is 9, and our K is 8. So how do we calculate this? We can just insert all the value into the formula, and we will write it as 9C8 multiplied by 2y multiplied by 3x to the power of 2 to the power of 8 plus 9C9 multiplied by 3x to the power of 2 to the power of 9. So we can find the answer for 9C8. We will get 9. For 2, we will get 2, and for 3 to the power of 8, we will get 6561, and yx to the power of 16 plus 9C9, the answer is 1. 3 to the power of 9, the answer is 19683, and you can just write 8 to the power of 8, x to the power of 18, because x to the power of 2 multiplied by 9, we will get 18, so it is x to the power of 18. After we calculate all the value, we can just multiply all the value with the value, which is 9 multiplied by 2 multiplied by 6561, and we will get 118098 y x to the power of 16 plus 1 multiplied by 19683, we will get 19683, and we just can write it back x to the power of 18. So we already solved the question. So the answer for the last two term is 8 term and 9 term. So the last two term is 118098 y x to the power of 16 and 19683 x to the power of 18. So that's all from me. Thank you.
Assalamualaikum and hello, my name is Maisarah from tutorial group SS2, and I will be presenting question 4 from set B. So first of all, it is important to note that this question uses a double inequality. A is lesser than x, which is lesser than b, meaning that a is lesser than x and x is lesser than b. So the value of x essentially lies between a and b. Also, the properties of inequality applied in this question include subtraction property, multiplication property, and also division property. So in the solution here, I have highlighted the parts where we apply these properties of inequality to make it easier to differentiate between them, and overall it is easier to view it that way. So let's move on to the question itself. First of all, as we can see, there is a fraction here in between -3 and 5. So what we first need to do is get rid of the fraction by moving the denominator to both sides. So, meaning that we will rewrite this inequality as so. -3 is multiplied by 3, which is lesser than 7 minus -4x, which is lesser than and equal to 5 multiplied by 3. Once we solve this, we will end up with -9 is lesser than 7 minus 4x, which is lesser than and equal to 15. So now that we're only left with 7 and -4x here in the middle, we will now move the 7 to both sides to leave only the value of x in between these two numbers. So we will rewrite this inequality as so. negative 9 minus 7 is lesser than negative 4x, which is lesser than and equal to 15 minus 7. So here we have applied the subtraction property. We'll end up with the answer negative 16 is lesser than negative 4x, which is lesser than and equal to 8. So now that we basically have left only x in the middle, we will now find the value of it by dividing both these numbers with negative 4. So essentially we will rewrite the equation, the inequality, as so: negative 16 over negative 4 is lesser than x, which is lesser than and equal to 8 over negative 4. So we can divide these numbers as we usually would, and we will end up with 4 is greater than x, which is greater than or equal to negative 2. So I've highlighted both these symbols here because the value of negative 2 cannot be greater than 4. So we will have to switch out these symbols in order to end up with a logical inequality here. So once we've done so, we can basically just rewrite the final answer as negative 2 is lesser than or equal to x, which is lesser than 4. So that is it for my part. Thank you so much for listening.
Assalamualaikum and hi, my name is Nur Maira Qaleesa 2400715 from SS2, and I will be explaining about question number 5. So for question number 5, the geometric progression has a first term log base 2 of 27 and a common ratio log base 2 of y. So from this question, the information that we can get is A, which is the first term, is log base 2 of 27, and R, which is the common ratio, is log base 2 of y. So we're moving on to the question A. Find the value of y for which the geometric progression has a sum of infinity. So if we refer to the formula of sum of infinity equals to A over 1 minus R, where the sum of infinity will only exist if the common ratio, which is R, lies between negative 1 and 1. So we will get the equation of negative 1 is less than R less than 1. So we just substitute the R that we get from the previous question, which is log base 2 of y, and so we will get the inequality of negative 1 is less than log base 2 of y is less than 1. So we will just solve the inequality one by one. So for this first inequality, log base 2 of y is more than negative 1. So we convert this from the logarithmic form into exponential form, which is y is more than 2 to the power of negative 1. So the final answer we get is y is more than 1 over 2. So the second inequality, we will just do the same as y is log base 2y is less than 1. So the final answer for the second inequality is y is less than 2. So from both answers, we can forget the final answer for the question A, which is 1 over 2 is less than y and less than 2. So for question B, find the exact value of y for which the sum of infinity of the geometric progression is 3. So from the question, we will insert all the information into the formula, which will lead us into log base 2 to 27 over 1 minus log base 2y equals to 3. So we do cross multiplication that will lead us into log base 2 of 27 equals to 3 minus 3 log base 2 of y. And we isolate the 3, that log base 2 27 plus 3 log base 2 y equals to 3. So 3 log base 2 of y, we can simplify it more using the law of logarithm into log base 2 y cube. So log base 2 of 27 plus log base 2 y cube, we can combine it into log base 2 27 y cube equals to 3. So from this equation, we can turn it into exponential form, which is 2 to the power of 3 equals to 27 y cube. So from 27y cube, we can simplify it more into 3y cube, and we can remove cube from both sides, and we will get 2 equals to 3y, and the final answer of y we will get is y equals to 2 over 3. So that's all from me. Thank you.